Hello. Don't mind the stack of crap right behind me. How we doing? Um, I'm not there. You're watching this video in class. Uh, Real quick, a quick synopsis. Today is 10/21, whoops, or 10/22. You're either watching this in class on Thursday or Friday, depending on if you're A day or B day. This is the last lesson of Unit 4, 4.8. Okay? Um, so we have this video and of course our big ideas assignment 4.8. The review is next class period. Spoiler alert, I will be gone again. Sorry. Um, Travels. I will be gone again. There will be a review video that I have created and you will watch in class next time as well. However, I will be home Tuesday night and I will still be streaming on Twitch Tuesday night before the test, which is Wednesday/Thursday. Nevada Day is Friday. We don't have school. I don't know if I'm streaming back to back nights. So B Day folks, um, Tuesday night stream. Let's go ahead and call it 6:30 p.m. Okay? Let's go ahead and call it 6:30 p.m. Tuesday night stream for everyone. Can't really guarantee a back to back stream that week, okay? So let us begin our notes. I already have some things filled in for us to make this a little bit quicker and easier, and we can jump into the assignment. Thank you, my sub, whoever's in there, or if a teacher's covering me, thanks for being there. Thanks for doing this. So this is already filled in here. I've already matched the functions. I literally just plugged each of these into Desmos and matched them up. So I just took care of that already. So if you want to quickly write that down, I'm just going to pause for dramatic effect here. Maybe that was enough time. So we've matched the graphs, and I went ahead and placed a little point at each of these, what are called turning points. So my little statement that I wrote here is the points marked are the turning points. We went from going up to going down and then back up. We went down and then we turned and went up and then turned and went back down for just a little bit. So those are the turning points. Okay? We're going to use that language here in a minute. So there's those functions. Um, yeah. All right. So how many turning points can the graph of a polynomial function have? Well, spoiler alert, I've already written the answer. One less than the degree. So that's how many it could have, not necessarily many it has to have. So let's go ahead and write that. Could have. Not necessarily, not has. Whoops. Not, how about I just say not a requirement? Okay. So if you look at these, you can see that the degree for C is 3, and it turned once, twice. That's it. One turn, two turns. For B, or sorry, which is E, it is a fourth degree polynomial, and it turned once, twice, three times. Maybe you can already kind of see the pattern there. D was cubic. It turned twice. Again, one less than a degree. So it doesn't have to, but it could. Okay. Um, so those turning points can be classified as local maximum and local minimum. Those turning points can be classified as local minimum and local maximum. So the maximums are the high turning points, and the local minimums are the low turning points. So the lowest and highest turning points, the low and the high turning point. So like going back up to these pictures, I could classify, hey, this is a local max and this is a local min because one's high, one's low. This one here is a local min and this one here would be a local max. So the high turning points being the maximums, the low turning points being the minimum. Like my camera is cutting off my chin, but what can you do? All right. So let's scroll down and do some problem. There's some cryptic math language, and I'm just not obsessed with how they phrase everything on here. I'd rather us just jump into the examples and yeah, let's rather have us jump into the examples. Actually, let's go ahead and put an X through this. We're not doing even and odd functions, so go ahead and put an X through that. All right. I know I had you just flip a whole bunch of pages. It's a little easier for me because I can scroll, but we're down to the practice problems. So just to give you a quick heads up, you're using Desmos a lot. So for number one, I have already plotted all of these functions. So here's function number one in red. So let's read the directions together. Graph the function, identify the x-intercepts, the points where the local mins and maxes occur, and then I crossed all this out. We're not doing these additional steps, okay? What I'm concerned about are the x-intercepts, in other words, where does it cross the x-axis, and where is the function turning? And we want to classify these as local mins and maxes, okay? So maybe I can do a little bit of a split screen technique here for us. So taking a look at the function over here, we can see that it crosses the x-axis at -1, 1.5, and 2.5. So -1, 1.5, and 2.5. So go ahead and mark those on our graph. You kind of need to give yourself an x-axis and y-axis first. So let's do that. And it crosses at -1, 1.5, so 3 halves, and 2.5, so 5 halves. Okay, so those are our x-intercepts, cross, cross, cross. If we wanted to find the zeros, that's what those are, right? Those are the zeros. And then we want to identify the local min and maxes. So we found the x-intercepts. Now let's do the maxes and mins. So again, it's just Desmos and clicking, right? We're not trying to make this too difficult. Desmos and click. Desmos and click. So if we click up here, up there at that high turning point, we have a maximum. So where is that? That's, I mean, just here's what I'm going to do. I'm just going to put a point way up here and label that the -0 point, what was it? 041, comma 15.021. So I just put a point up there. So this is a maximum, local max. And then we have another point at the bottom. We have another point at the bottom, which is 2.041 and -3.21. So if I kind of zoom in over here, 2 to the basically 2 to the right, 2.041. Oh, my webcam is covering it. That's my bad. I'll move it up there. So there you can see the point. So 2.041 and then down to basically -3. So I'm going to put it right there. And that is a local min. And if we connect all the dots on this and draw our pretty curve, of course it's going to look like Desmos, right? There it is. So it's vocab that we're trying to get good at. Vocab and identifying those things on the graph. The x-intercepts are where it crosses the x-axis, often referred to as the zeros. And then the local mins are where the turning points are at the bottom, and the local maxes are when the turning points are at the top. If you're curious what these things might look like on big ideas, um, well, here you're just matching the function to the graph, so you're just plugging it into Desmos. But when it starts to talk about min and maxes and whatnot, like here it says, what are the zeros? That's just where it crosses the x-axis. Or here it says, what are the turning points? So they've given you some options down here, and you're just matching them to the correct turning points, okay? And then identifying which one as a min and which one as a max, okay? Um, so I hope that is kind of satisfying your curiosity there as to what this might look like. Just identifying these different ingredients. So let's do another one together. I've plugged them all into Desmos so we can take a look at them. What are we at here, runtime? Only 12 minutes in. I'm hoping you're already feeling confident 12 minutes in. So looking at the next function, it crosses the x-axis once, twice. Can I zoom in? There we go. Once, twice, two times, three times, four times. So go ahead and do your. I mean, obviously though a couple of them are the weird decimals. So I'm just going to 1, 2, 3, 4, 5. Put one here at -4.562. I don't know what fraction that is offhand. And for the sake of this lesson, I'm not as concerned, right? Because I'm just trying to know what the graph looks like. Those points are and get used to the vocabulary. Those points are the zeros. And then I want to find my highs and lows. You can even see here on Big Ideas with this example that it's using a decimal. Okay, so we're not as stressed about being exact with these. It's more about getting used to, again, the vocab. Okay, so -4.562, -0.438. That's basically a half. I'm going to put one right here. And then one at 0, 0 right there. And then one at 2.5. So I know what fraction that is. That's 5 halves. So those are the x-intercepts because that's where it crosses the x-axis. And then where are our turning points? Let's go ahead and blow this up. So our turning points, we're a little crazy here. We have one here. Let's do that one. That one's simple enough. I can spot that one. Do your best to plot that on your graph here. I mean, right about there. -0.223, comma 1.135. So just do your best to plot that where you feel like it should go. Again, we're more concerned about the point than we are maybe how exact your graph is. Because to be honest, are you really going to graph any of these by hand? No. Looking at the graph down here, at this turning point, that's to the right 1.5, and then way down. Obviously, I can't plot that on my graph, so I'm just gonna pretend as if I could. Here, I'll show you what I did. I'm just pretending as if it's there, right at the very bottom. -36, I mean, that's like way down, but I can't plot that, so I'm just doing that. So our function's coming together here. It goes. It's about to go down again and then come back up one more time. Right? That's what this function looks like. I mean, it's my function looks way simpler than this crazy looking thing. But I gotta zoom way out to find this low turning point here. And there's the last one. So negative 3.336, comma, negative 138.272. And again, I just put it down here. Our drawings are not exact by any form of that definition, right? They're very inexact. What I want to know is that you can find the points and that you know what to call them. So let's label them again. The low turning points are local mins, and the high turning point is um, local max. I don't know why I just had a brain fart. Local. Here, let's skim big ideas together, see if there's any surprises. This is the assignment that you're about to crack open. Per usual, feel free to talk to each other. Um, Clearly use Desmos to plug all these things in and match it to the correct graph. That's pretty simple. Um, so you want to state what mistake they made with their graph. Plug it into Desmos, see where it went wrong. Finding the zeros, again, that word zero just is another word for x-intercept. Where does it cross the x-axis? Um, Turning points we've discussed. Okay. Let's do one more for good measure. We'll probably cap it off at the 20-minute mark. Okay, one more for good measure, and that'll cap us off at the 20-minute mark. So I have them all plotted. Oh, by the way, I wanted to show you this. Isn't this wild when I have them all plotted? Isn't this wild looking? I don't know. I just thought that was kind of funny. Let's do number five. Let's do number five. Where is it at? Can't even see it. Oh, wow. Does it come back down? Oh, it doesn't even come down. Interesting. So this one doesn't have. Let's do one with x-intercepts. That, in a nutshell, that doesn't have x-intercepts. It just has that one minimum point at the bottom. Okay, let's do one that crosses. How about this one? X cubed minus 2. So this is number 4. So the x-intercepts on this one are about negative 1.5, 0, and about positive. That's a square root, right? Because you got plus or minus. That's a square root. 1.414. That's the square root of 2. Look at that. That's the square root of 2. 1.414. So I'm going to go ahead and write square root of 2 on my graph. That you would have to, but you know, I'm just trying to get you in the hang of these things. So I'm going to write square root of 2 on mine. So negative root 2, positive root 2, and what was the other one? Oh, just 0. So those are my x-intercepts because that's where it crosses the x-axis. And then my turning points, let's go ahead and zoom in a little bit more for you. My turning points are up here, which that point is, let's just go ahead and say it's like right here on my graph. And that's negative 0.816. And then this point is basically in the same spot, right? Yeah, it's just in the same spot except down. So right there, 0.816 and negative 1.089. And hopefully you can beat me to it here. This is a local. The first one right here is a local max. And this bottom one is a local min. And when we connect our beautiful points together, we get a graph that looks like that. Gorgeous. How lovely, right? All right. Um, before you close this out, whoever's in control of the video here, just please, let's all get started on big ideas and try to knock this out. We clearly have a lot of time because this video is not very long. If you finish this assignment, which ideally you do, take a look and make a game plan for yourself for over the weekend here for what you need to finish. Assignments are closing soon. The test is coming soon. We are reviewing next class period and testing the period after that. Okay? We are reviewing next class period and testing the period after that. So assignments are locking at the end of the unit. So you have some time this class period to potentially do some major damage and knock some stuff out. So don't take this extra time lightly, all right? Don't torture yourself. I'm rambling at this point, but I just really want you to use the time. Okay? So I leave you to the big ideas. Um, I am emailable. Random thought. I am emailable. So if you might catch me and I might reply. Okay, I can't guarantee my promptness, but I'm out there in the world. So yeah. All right. I'll catch you later. Have a good rest of your day.